Alright, no takeovers now. This is it.
So I'm presenting ovarian development in the black widow spider. What we were observing primarily was the formation of yolk inside the oocytes. And the oocytes are just another word for egg cell. What we know about black widows is that they are able to produce multiple egg clutches from a single mating. And they're able to do this because just from mating with a male spider once, they are able to store their sperm and use that for fertilization in later months. So pretty much what we have here is just a timeline from pre-vitellogenesis to post-vitellogenesis, meaning before egg formation and then completion of egg formation inside the oocyte. So what we have here is just an ovary, and attached to it are multiple oocytes. And the oocytes remain attached to the ovary via a funiculus, which is just a multicellular stem. And here you can see light microscope images that show very smooth oocytes. And they're pretty small compared to an oocyte over here that's more developed and has egg yolk formation. So what we have also is the oocyte attached to a stem here, funiculus. You can see that here with these light images, and also here with this transition electron microscope image. You can see the inside of the multicellular stem, and you can see that it has structure. So from here, we see our timeline from beginning to end. Right here in the pre-vitellogenesis state, we have oocytes that are very smooth and very small. You can see here from the scale bar, it's quite large here at 100 microns, and then it gets quite small, meaning that the eggs are getting quite large. You can see here that there is diffuse cytoplasm, and just these dark grains here are mitochondria. In this next state where you see vitellogenesis occurring, we have granular formation on the oocyte, meaning that egg formation has begun. This light microscope image illustrates that egg yolk formation has begun, but still it's in the process as the inside is smooth. Over here we have post-vitellogenesis. Yolk granules are seen throughout the oocyte. And on the inside here you can see what the inside yolk granules look like. What we have here is just a little empty space where the oocyte detached from the funiculus. What we know is that after yolk formation has occurred, vitellogenesis is complete, and then the oocyte just pops off. So that leaves the question for where does it go after it pops off of the funiculus? And what we know is that it just floats around in the abdominal cavity. But the question is, how does it get back through the ovarian wall and into the oviduct? The eggs need to go through the oviduct in order to go through the gonopore here in the oviduct and get fertilized by the sperm. And then once fertilized, the eggs can be released. And then here we see that the black widow spider is encasing the eggs in her cell. So the big question is, how does it get into the oviduct? You know that it can't really get in through via the funiculus. For one thing, it would make sense for it to detach and then reattach itself and go through. Also, the funiculus doesn't have a lumen. There's no way for it to travel through. It's just a structure here. It's just a stem. So what we suggest maybe is that the structure of the ovarian wall changes after detachment occurs, which perhaps would allow the egg to somehow pass through the ovarian wall and into the oviduct. There's still a lot of research to be done, so we're going to focus that in the future.